Shaping a sustainable future of flight. That's what GKN Aerospace are here at Farnborough International Air Show 2024 to do. I'm joined here by Max Brown, who is VP of Engineering and Technology. Max, thank you very much for joining us. Tell us what the big stories are that you're hoping to share with visitors to this year's show.
Yeah, thank you, David. So really exciting day for us today here at Farnborough. We announced this morning our latest programme, new project, collaborative project in our hydrogen systems portfolio, and that's the H2 Flight programme.
H2 Flight, what is that?
So H2 Flight, it builds on some of our previous programmes that we've launched over the last few years, and it is the next stage in the journey to develop zero emission hydrogen propulsion systems for sustainable flight.
Now, you're partnering, there's a collaboration with the UK government as part of this. Tell us a bit more about these programmes, the differences between them and the role that the government plays to help bring this technology to life.
Yeah, so collaboration is absolutely critical in what we're doing here. We collaborate with some of our key industrial partners, but we also have really strong collaboration with governments as well. In the context of H2 Flight, the UK government plays a key role in that, and they allow us to explore areas with a level of security in what we're doing and really enable us to push the boundaries of innovation and hopefully, in the case of the UK government and this programme, secure some really strong intellectual property for the UK.
So, announcement today, great to have that here at the Air Show. What are the milestones, what are the next steps now, and what do you hope to achieve?
Yeah, so H2 Flight is a 5-year programme. It's a £44 million investment. We'll be taking the technologies that we developed in the previous programs like H2 Gear, and we'll be scaling those up to flight-ready capability. So this is really taking our fuel cell technology, our cryogenic electrical networks, and our cryogenic electrical motor, and we're scaling that up to 2 megawatt type applications so we can really position it for the next generation of aircraft.
So what kind of timescales are we looking at then for flight-ready commercial operations using this technology? All
of our technology building blocks at the moment are being sort of positioned towards the end of this decade. And then what we're really looking at is the mid-2030s. We'll be looking at some entry into service for some regional aircraft applications.
And in terms of the positioning, the environmental impact of hydrogen as an aviation propulsion, where are we really on that?
No one solution is going to solve the problem, but if you're just purely talking about emissions, then the route to zero emissions is hydrogen. Right. So there's zero CO2, there's zero NOx, you do see some contrails, but the route to getting a zero emission solution would be to put a hydrogen solution in place. There are other factors that you need to consider in that, like the supply of the fuel, like the infrastructure needs to be in place to do that. So as I said, it's not the whole solution, but it's very much part of that solution.
And with programs like H2 Flight and so on, these are stepping stones towards that vision. Yeah,
we have a portfolio of programs. So right the way from as the fuel goes into the aircraft, the hydrogen, liquid hydrogen fuel, we have the High 5 program. We then have the H2 Gear program, which looks at the propulsion part of the architecture, and then we bring it all together under H2 Flight for a full system solution.
Exciting times. We'll leave it there for now though, Max. Thank you very much for chatting us through that, and look, all the very best for the next 5 years of this programme.
Thank you, David.